Welcome to week 9. We are almost there, y'all. Like, we are literally almost there. So let's kick this course off right this week, right? We know that we're going to be working on our knowledge checks. We're going to have some poll questions in the end with some random knowledge checks. We are also going to go over the apply and reflection as well as our highly missed questions. This week, we are going to do something different for those who are watching the playback. Are there any books, movies, or TV shows that you've enjoyed recently that you could recommend? And why would you recommend them to me? And let's talk about a good read in this week's discussion forum. Now, our math trivia. What was the number 0 originally called? It was a cipher. Cipher comes from the Arabic word cipher or sif, S-I-F-R, meaning empty. So the first known use of the word 0 was in 1958. And per Albert Einstein, pure mathematics is, in its way, the poetry of logical ideas. Now for our highly missed questions. Ironically, the most missed questions, the highly missed questions were true and false, okay? So actually, yeah, they're all true and false questions. So let's go over them. From chapter 9, determining the location of a health record is part of the release of information process. That is true. Because remember, in the release of information process, that is one of the things they're looking at. They're looking at where that record is. Okay, so that is true. The next question, postage and service contracts are considered non-labor costs. True. Loose papers that present to the HIM department may be a significant factor in determining staffing levels. True, because that would be another task that that individual may have to do on top of other things. True or false? Whether a coder is coding outpatient overnight stays or inpatient length is a factor in the productivity standard for the coder. Again, true. This is anything that's going to be in addition to their normal coding responsibilities and duties. Total hours worked are the number of hours worked by the employee to produce work, which includes time for meals, breaks, and false. Remember, when we are accounting for time or FTEs, we are not counting their 30-minute meal break or including any types of breaks or meetings. So that particular question is false. It's just your straight hours, okay? True or false? Completed work output is work output multiplied by completed work percentage. True. Number 7, the number of FTEs will always equal the number of employees. That is false, because remember, sometimes you may have part-time or per diems that are not going to be full-time employees. So the number of FTEs does not always equal the number of employees. All right, and then for our knowledge checks. Whether a coder is coding outpatient overnight stays or inpatient length is a factor in the productivity standard for the coder. That is true. And the average work output per hour is work output divided by total hours worked. That is also true. So what I'm going to do is really look at the questions for the final and really go over to see the potential true and false questions so that you guys have a good idea. And then we're going to hone those in on our Quizlet. Like, I'm going to really kind of hone that in on that review so that you guys are really prepared, because a lot of, I'm noticing the highly missed questions, especially from this week, and even I want to say last week, there were a lot of missed questions with true or false. So I'm gonna really hone in on those for our final, okay? Now, this week in chapter 11, we are really just talking about how we present data, okay? Show and tell, as it says on the slide. So for our learning objectives, we are going to be looking at different terms: nominal, ordinal, interval, ratio, discrete continuous data types. We're going to be looking at the different types of tables and graphs. I believe you guys have to create a table and graph to display statistical information, or at least look at that type of information. And then we are going to be discussing the basic elements of a report. So we look at descriptive statistics. Now, the most common type of statistics that the health information technician will encounter or be responsible for producing is this type: descriptive statistics. You're just looking at describing populations like your patients, medical services, nursing units, hospital departments. You are really getting and providing an overview of the general features of the sets of data that individuals are going to be reading and they're interested about within a particular hospital environment, or healthcare environment, I should say. So we look at our categorical data, okay? We're talking about, as you can see, nominal naming scale, where things are just named or labeled. There's not in any specific order. You have your lowest level. Nominal means pertaining to a name, just as it says, nominal name. So you may have examples like your true or false, male or female, different types of insurance carriers, Medicare, Medicaid, VA, and then maybe a patient's occupation: nurse, doctor, physician, lawyer. Yeah, he's going to get that. Now, numbers may be used to represent those different categories. Males may be listed as 1, females may be listed as 2. Persons may be grouped by blood types, where 1 would represent your A, 2 B, and so on and so on. When we look at ordinal, now the scale has variables, okay? Values are ordered in categories. On the ordinal scale, the numbers are going to be meaningful. Head injuries, for example, they can be classified according to a level of severity. You have 4 meaning fatal, 3 severe, 2 moderate, or 1 being minor. There's a natural order existing among the groupings. The largest number represents the most serious level of injury. The order can, of course, be revised. Intervals between orders, the categories, they're not going to be considered or assumed to be equal. Okay, so the intervals between each are not going to be considered equal in most cases. Now, numerical, yeah, I just made up a term, that's okay. Numerical data refers to the data that is in the form of numbers, and it's not in any language or descriptive form. They're often referred to as quantitative data, right? Numerical data is collected in number form, and it stands different from any form of number data types due to its ability to be statistically and arithmetically calculated. Okay, you can count it. We also have our interval data, also called the integer. It's defined as the data type which is measured along a scale. It includes units of equal size. There's no 0 point. Example, temperature. They're in Fahrenheit degrees. The intervals between the values are going to be pretty much the same. The most important characteristic is that the intervals between values are equal. So just keep that in mind. We have ratio data. The difference between interval and ratio is simple. Ratio data has a defined 0 point. Income, you either got no money or you got a lot of money. Height, weight, annual sales, market share, product defect rates. They may be displayed by units of equal size, 0, 5, 10, 15, 20, right? Age, the difference between any 2 years would be the same. The difference between age 1 and 2 is 1. 2 and 3 is 1. 3 and 4 is 1, and so on, right? We also have what's called discrete data. Now, we look at the example here would be the number of family members, or the number of children in a family, be more specific. Number of children in a family. A family can have 2 or 3 children, but you're not going to find someone saying, I have 2.25 children, or I have 3.75 children. Where's the 7.75? Where they're at, right? So you either have 2 or 3 or 4 children. You're not going to have decimal place of children, okay? Now, other examples, the number of motor vehicle accidents in a particular community, the number of times a woman has given birth or has been pregnant, the number of new cases of cancer cases in your state within the past 5 years, the number of beds available in your hospital. Okay, now we're bringing it back to healthcare. There's a natural order, okay? The difference between 1 and 2 births, again, is the same as the difference between 4 and 5. Number of births is restricted to whole numbers. Again, a woman cannot give birth 2.3 times. She's either given birth 2 times or 3 times. The chapter also talks about continuous data. An example, a measurement of temperature may be 102.6 degrees Fahrenheit. A height, one could say that someone is approximately 6 feet tall, and then they can break it down even more and say, no, they're 5 feet 11. Or they can get really specific. Sometimes I'll do this and say I'm 5'7.5", right? Like, okay, where's this half come from? But you're doing that, right? You're still refining it even more. And then age, you may have been 20 years old on your last birthday. However, let's say your birthday was in January. So you turn 20 in January. Now you're technically 20 years and 4 months come May. Okay, so you're 20 years plus some part of another month, or in this case, 4 months. When we look at numerical factors, we can kind of categorize age again. If you ever go and fill out some surveys, they'll have ages grouped 0 to 20, 21 to 30, 31 to 40, right? So they're categorizing the groups. We look at measurements on intervals. Interval and ratio variables are continuous, okay? And I really like this particular slide because it breaks things down when you're looking at precise, accurate, precise, inaccurate, etc., etc. You guys can see that. We look at tables, okay? Almost any type of quantitative information can be grouped into tables. Columns allow you to be able to read the data up and down while you're still being able to see rows, and you can also read across. Okay, just make sure that the chapter talks about having things labeled, especially if you're going to be that individual that is responsible for putting this information together. We've done all of the statistics. We looked at adding the turnover rates, the bed counts, and now you're putting them on for display for the presentation. Okay, so this is where this chapter is coming in. We look at how the information can be presented. Less work and fewer costs are required in the preparation. You can kind of see that adding charts and graphs really will hone in and have your audience really kind of figuring out, okay, so this is what we're talking about. This makes sense. Our bed turnover rate has gone up, or our inpatient bed status is at this level where it was at a certain level a month ago or a year ago. Okay. So how are you bringing these? How are you displaying this table for your potential report that you're giving, maybe to your stakeholders, maybe you're giving it to the board of directors? Well, you're just making sure that your tables, everything's looking professional, okay? You're identifying the right information. The title must explain as simply as possible what this table is portraying to them. You have your head note, which is just a short kind of explanatory note that applies to the different tables. Your captions are referring to the headings, right? You have stubs, which are the categories on that left side. You kind of see that under your stub heading. You have your body information that's going to be formed to kind of say, hey, this is exactly what is going to be presented. This is what we're talking about, okay? We look at frequency distribution tables as well. Now, you're not going to use fewer than 5 or more than 15 categories. Your categories are going to, again, be well defined. They are going to make the classes cover equal ranges in different intervals. All right. Now, towards the end of the chapter, we're going to start looking at how and what these graphs are going to look like and what they potentially could mean as we get into graphs, right? Now, with these graphs, they should be easy to read, simple in contact, and make sure that they're labeled correctly. Pretty simple, right? There are different guidelines. The title must relate to what the graph shows as simple as possible. Sometimes you may have a particular audience. You're not going to have the same maybe terminology when you are presenting to, let's say, doctors as you would the IT help desk or that staff, right? So you're going to make sure that you are really communicating to your audience. You have your legend or key, and then your categories are going to be neutral, okay? You're going to have things on your vertical axis. You're going to start with 0, and you're going to go from there. Now, let's break down these graphs. The chapter talks about bar graphs, one of the very first things they bring up. Simplest bar graph is a 1 variable bar graph, right? You have categories, again, along the horizontal or x-axis. You have your vertical or y-axis that's going to have frequency of the data. A grouped bar chart is used to really just display information from tables that contain only 2 or 3 at the max variables. Your pie chart. Now, it's just a circle. Think of it as it's just a pie. It's different parts. It's going to represent 100% total. It's going to be or must be converted to a percentage as when you are displaying this information. And they're just little cute wedges, and they can be cut out of a pie to help really emphasize the different percentages that you want your audience to know about. Your line graph. When we talk about different examples, days, weeks, months, or even years, your x-axis is going to really show the period of time, whereas your y-axis is going to show the variables, okay? Now, the cool thing about the line graph is that it allows for several variables to be plotted. Oftentimes, you may see a histogram. Now, the difference from a histogram and a bar graphs display data that fall into categories. Histograms illustrate frequency and the frequency distribution of continuous variables. So that means that histograms are created from frequency tables, kind of putting it kind of in perspective. You have, when we look at your bar graphs, making sure that they're equal. And this one is a little bit more than 12, but you guys can get. They should not be less than 4 and usually never more than 12 bars or classes. And they should not overlap, okay? We look at our frequency polygon. Now, this is a visual representation of distribution. It can be used instead of a histogram, all right? It's similar to a histogram, but frequency polygon is a line form instead of a bar form. There's different advantages that the chapter brings up. It uses the same accesses as the histogram, but a dot is placed and then connected by a line that is drawn from the point to the next point, okay? And then sometimes you're like, you know what? I am just going to show pictures, and you'll use a pictogram. If you want to show the number of individuals, sometimes you can even use stick people if you're not that good at drawing. It can be one of those entertaining, breaking the silence, right? And it can catch the attention of your audience because they're expecting to see all these things. Then you're like, hold up, bam, first slide, here's some pictures. And then you get into almost like an icebreaker, getting into the information as you're getting ready to go over whatever data that is required for this particular presentation. We also have a scatter diagram. It is used to examine the relationship between both the X and Y. We look at correlations, okay? The chapter, and I have seen questions on the slope of the line being positive or negative, okay? So I'm gonna kind of go over it because, like I said, I have seen questions on this. Now, when we look at it, a positive scatter diagram, you have small values of the x-axis corresponding to the small values of the y-axis, and larger values of the x-axis correspond with larger values of the y-axis. That is saying that there is a positive linear relationship. So small to small, large to large, okay? With a negative scatter diagram, small values of the x correspond to large values of the y. So think positive, xx, or small, large. Negative, small, large, okay? That is going to be a negative linear relationship. Like I said, I have seen questions where they are just asking you, you know, if you were to see a scatter diagram and the X and Y values are both small or vice versa, would that be considered a negative, a positive, etc.? Okay. And then now you're ready to report. You're ready to stand in front of your audience and provide them the information that they are so eagerly waiting for. You are reviewing reports. You've given them to the committees or your administration, and you're just giving them that as a guide as you're going over that information. All right. So there are general guidelines. Table shows should summarize and be very detailed. Your graphs are going to be more useful for presenting relationships and for visualizations. Making sure that you understand who you're talking to, who is your audience, okay? That's gonna help to decide what you include in your report. For example, if you know that you have to give reports to, let's say, 4 different departments within a week. You have oncology, you have OBGYN, you have surgery, you have the ED, and you have pharmacy. Well, pharmacy is not gonna necessarily want to, they're gonna care, but they're not necessarily going to be so interested in the amount of oncology patients and their issues, right? As well as the ED may not be as interested in the amount of surgical turnovers, okay? So you're going to really want to hone it in to who you're talking to, who your audience is. You make sure that you prepare a narrative. You may even want to go over it a couple of times and look at historical data. Include factors that influence seasonal changes. Maybe there was a reason for a influx of influenza patients in the ED. Well, what time of the year is it? Maybe it was around flu season. Well, that's going to kind of put things into perspective. On the other end, if it's in the middle of summer and all of a sudden you have a lot of patients coming in with signs and symptoms of influenza and whooping cough, you may want to sit back and be like, okay, what's going on? Also include your sources, make sure your information is correct. So trust but verify, and then proofread for any inaccuracies that may be in the report. And believe it or not, that is the end of the chapter. Now, for everyone who is comfortable, they have a good idea about the knowledge, or not the knowledge checks, the apply and reflect, this is where I say have a wonderful rest of your week. And I will see you in next week's live session. But for those of you who kind of want to just see a little preview of what this week is about, stick around. So the very first exercise, there's just 9 multiple choice questions for exercise 1. Okay, kind of not too bad. And then the second one, you do have a break from any type of math. However, you will be creating a bar graph and a pie chart from this information that is provided in the apply and reflection. And what you're going to do is you're just going to make sure that you submit both graphs in the submission box for credit. Okay, and it tells you exactly what you are graphing. For the bar graph, you're going to use live discharges. Okay, there you go, and deaths for each service listed. And then the second one is just creating a pie chart showing the discharge days for each service. Which brings us to the end. For those who are watching the playback, are there any books, movies, or TV shows that you've enjoyed recently that you would recommend? And why would you recommend them to me? What was the number 0 originally called? It was called a cipher. Remember that cipher comes from the Arabic word sifr, meaning empty. And pure mathematics is, in its way, poetry of logical ideas. That was by Albert Einstein. We went over the highly missed questions. Like I mentioned, there was a lot of true and false. So I will be definitely breaking down our final and just figuring out kind of how many multiple choice, how many true and false. So that way I can really kind of guide you guys on what to really focus on, especially because this is cumulative and I want y'all to blow it out of the water. Okay, we went over chapter 11, so we had a little break from our calculators and we went over presentation of data. Your apply and reflection is pretty cut and dry, and this is our wrap up. What questions do you have for me this evening? If there are any questions? All right, I see the chat is empty. So on that note, I hope you all had a wonderful Memorial Day weekend. I hope you have a wonderful rest of your week. Thank you guys for being here in week 9. And then have a wonderful, wonderful weekend. And I will see everyone who can attend at our normally scheduled session and next week's live session. Have a good night, y'all.